Group 21 was assigned to design a portal frame structure based on specific parameters provided by the client. The structure was designed and analysed using Autodesk Revit and SpaceGas, enabling the team to meet the structural requirements outlined in the brief, with a 3D model of the design shown below. Key parameters include a building length of 20 metres, a 16 metre frame span, a structural slab thickness of 400mm, and an 8 metre eave height. The frame needed to be designed to support rafter loads of 12 kilonewtons per metre. The cladding specified is spandex, and the roofing sheeting is Clip-Lock Classic 700.
The dimensions and spans of the columns, rafters, girts and purlins used in the project meet the client's specified design parameters. Once these members were selected, the portal frame was modelled in Revit and then transferred to SpaceGas for structural load analysis and integrity assessment. Group 1 selected appropriate universal beams for the columns and rafters to comply with the client's requirements. An appropriate portal frame spacing of 4000mm was selected to simplify the design process. The spacing also acted as a double span for the purlins and girts, which have a length of 8000mm, with 4 members covering the entirety of the length of the building. The purlins and girts were spaced according to the maximum support spans for the roofing and wall cladding. The purlin spacing ensures that the roofing adheres to AS4100 Australian standards and can withstand wind loads up to 1 kN per metre. Lysat spandeck was used for wall cladding, requiring the design to incorporate maximum feasible spacing, and the team selected internal spans based on the spandeck support spacing catalogue. A base metal thickness of 0.42mm was chosen, as it satisfies the design spans within the necessary constraints.
At the client's request, a mezzanine level was incorporated into the design. Group 1 proposed an 84 square metre mezzanine level along with 10 windows, 4 large skylights and 2 doors, 1 fixed and 1 large roller entry. The inclusion of the large skylights and numerous windows provide an abundance of natural light and thermal benefits for the warehouse. After the completion of the portal frame design, it was transferred to SpaceGas for further analysis to ensure it complied with the AS4100 standards. As the intended location for the structure is in Wollongong, this means it lies within the A2 wind region. Through extensive analysis, the following structural loads were extracted: dead load, live load, internal longitudinal winds, internal crosswind, and external crosswind.
The previous structural loads were then used to create the following combination load cases as seen on screen here. There are 2 groups, the strength limit design, G plus Q, and the serviceability limit design, where there are 4 different load combinations. A design check was then performed using SpaceGas, confirming that the portal frame structure complies with the AS4100 standards. However, the design check also revealed that the structure is perhaps over-engineered, as indicated by all the green members on screen. This suggests that the structural design can be optimized and money can be further saved by using smaller columns or rafters to achieve the load factor closer to 1. Additionally, the warehouse design includes special features that allow for further cost savings by conserving water and generating solar electricity. Diagrams of this can be seen on screen.